Well, hey everybody, we are starting to go back to the different sections, all the different forms of solving, whether it's one step, two steps, variables on both sides, having to combine like terms on one side. It really doesn't matter what form of equation we have. There's going to be times when we end up with fractions and decimals, and sometimes we don't want to work with them. So there are tricks that we can use to get rid of them, as I've noted here in our notes. It's not so bad for fractions. We have to multiply everything by the greatest common denominator. And for decimals, we have to multiply everything by a power of 10. Remember that multiplying by 10 moves the decimal one spot, multiplying 100 moves it 2, 1,000, 3, and so on. So if we can remember that from the past, it's like a blast from 4th and 5th grade, we are able to get these done pretty quickly. Okay, our first one that we look at here, not a big deal. Look, we have only one fraction in this. Our denominator is 2. This is like 3 over 1, so the greatest common denominator is a 2. Notice what I'm going to do here. I'm putting the entire equation in a set of parentheses. And we're going to multiply everything by 2. So 2 times 3 is 6. Notice when we do 2 times 7 over 2, it turns into just 7. And these parentheses kind of like protect this because this leading constant here is what's going to be multiplied by that 2, so it takes care of it. It'll eventually all be multiplied out by that. You just rewrite this exactly as you see it. Otherwise, you would have had to like distribute this thing and then multiply everything by 2. You don't want to do that. Get rid of the fraction where it sits. All right, so now this is a simple equation like we have been doing. We're going to go through here and we take this. What 7 times 3 is 21. 7 times a minus 4 is a negative 28. Carry down your 6. Notice these are not, we're solving for y. It's not by itself, so you have to add 28. You might be noticing, hey, Mr. C, we're not doing all of our little scales and stuff. No, because, you know, as we start to get better at these, those lines and stuff that we draw for ourselves and boxing in the variables and that, those are all techniques for us to get better at it. Once we learn it, we start to do it effectively and efficiently. You know, we don't have to always be drawing these things. So now these will cancel. And if I'm going to add this up, I will switch colors, though, because colors help us identify sometimes when we are switching over to a new step. So 28 and 6 is 34. All right, and we divide by 21. All right, so 21's cancel, and we're left with, we're left with a big fraction. Is that fraction, does y actually equal 34 over 21? Well, yeah, it does, but we have to look at, is that fraction reduced? So sometimes ones like this is not the easiest one to look at and see, you know, well, what makes 21? Well, 1 and 21, 3 times 7. 3 is a prime number, 7 is a prime number. So, you know, we're looking at this as, I can tell you now that this is not going to reduce, but you can always double check this in your calculator. Our calculators have this little button that's right below the shift, because we're using the Casio FX260. Right below the shift button is this ABC button. It's like A, and it's like a B divided by C. So we would type in the number 34, ABC, 21, and hit equals, and it changes it into a mixed number for us. Then we hit the shift ABC again, and it will reduce it. It'll give you its smallest reduction. And if you do that in your calculators, you'll notice that it comes out to 34 over 21. And that's it. You're done. So you can say, yes, I know that this is my answer. I have double checked it. I made sure that this fraction is in its most reduced form. Now we look at the next one. I'm going to tell you that when you see one like this, where we're looking at things with, there's pieces up here. We have what? 2 terms in the numerator. You wrap these in a set of parentheses. Okay, wrap them in a set of parentheses before we start anything. Now we have to look at all of the numbers that are here. We have a 6 and we have a 12 in the denominators. So between those two numbers, what is the greatest common denominator? Hopefully we said 12. So that means that every single piece has to be, this has to be multiplied by 12. This gets multiplied by 12, and this gets multiplied by 12. We're distributing a 12 to every single piece. Okay, so 12 divided by 6 reduces to a 2. And this is why we do this, because it makes our entire problem go from these crazy fractions to just something so much better. 12 divided by 12 is 1, so literally all this can just come straight down. And negative 3 times 12 is a negative 36. So we have to distribute. All right, so we can distribute. I'm going to switch colors. We have a 6x minus 2 plus x plus 1 equals negative 36. We should be saying, hey, I can clean this up too. I've got all these. I have a 7x, because 6x is plus 1x is 7x. And I have what? A negative 2 and a positive 1, so that's a minus 1. So now we should be able to see that this is not so bad. This becomes a nice, easy little problem. I will go ahead and switch our colors one more time. So to solve this, notice the x is stuck in here. We have to get rid of the 1 first. Sometimes I'm noticing the hardest things we're doing, right? Remember, this is where we'd put that little scale if we were still doing it, is we are not doing this addition and subtraction, right, guys, for positive and negative numbers. This is like a 4th grade thing that we have to just start to do better at, all right? Negative 36 plus 1 is a negative 35. We carry down our 7x and notice, yes, x is not by itself. Divide by 7. And hopefully our division skills and this negative divided by a positive becomes a negative. 35 divided by 7 is a 5. Nice, pretty numbers here. Again, multiplying by our denominators helped get rid of a lot of this. Maybe in this one it wouldn't have been so hard, but in this one it really saved us some work, because this is not like, it's just not fun. All right. Let's look at this. Here we go. We've got this example here. Not too bad, but we have to look and say, okay, this is what? There's no decimals, no decimal spots. 1 decimal place, 1 decimal place, 1 decimal place. So because I'm only trying to get rid of 1 decimal place, I'm going to wrap this entire equation in a set of parentheses, and everything inside those parentheses are going to be multiplied by 10. This, of course, is protected. The tricky part on this one is right here. Look, we have to remember there is like a hidden negative 1. First thing I'm going to do is just bring that whole set of parentheses down. All right, now we start distributing our 10, and we'll notice what 10 times 6.8 gives us a 68. 10 times negative 3.9 is negative 39. 10 times a negative 1 is a negative 10. And 10 times negative 2 is negative 20. Why? You can suddenly see that this is starting to get much easier. We don't have all these little decimal points that we're messing around with. It makes life so much simpler. Now, as we look at this, okay, let's switch colors so that we can start to identify what we're doing. We have to distribute this negative 10. So a negative 10 times a negative 8.9 gives us a positive 89y. Negative 10 times negative 1 gives us a positive 10. Everything else is going to come down. And now we have to say, okay, I have some like terms to combine. I have a negative 39 and a positive 10, so this is a negative 29. Negative 20y and a positive 89 gives me a positive 69y. Now we're pretty much at the very end of this particular equation. I'll switch colors again so we can see this next step. We need to move all of our variables to one side. So I'm going to subtract 69y. Negative 69 positive 68 leaves me with a negative y. These all canceled and minus 29. Notice I know some people want to say, okay, we're done. Now look, this y here is not by itself, so you have to divide by negative 1. So we end up with y equals negative 29 divided by negative 1 is a positive 29. Now you're done. And that's how these work, guys. Nothing is too bad. We have to just remember, be careful when we multiply. If you almost always, if they give us something like this, it's going to be that minus, so that we have to remember there's an invisible one there that we're distributing this 10 here to. And then we distributed it to this, we distributed it to that, and you distribute it to this. We leave those parentheses alone because it ends up being multiplied by a power of 10 later on. All right, that's it for these. Not so bad. All the skills we need for this we've previously learned. We're just learning how to manipulate these to get rid of our fractions and to get rid of our decimals. That would be it, guys. Get out there, do that homework. Have a good day.